Next, let me show you the signs of trigonometry functions in different quadrants. We know that in the coordinate plane, sine theta is always y over r. Cosine theta is always x over r. Tangent theta is always y over x. And cotangent is a reciprocal of tangent. That's x over y. Secant is a reciprocal of cosine. That's r over x. And cosecant is a reciprocal of sine. That's r over y. Those are the 6 trigonometry functions in the coordinate plane. And we know that in the coordinate plane, there are 4 quadrants. Quadrant 1, Quadrant 2, Quadrant 3, and Quadrant 4. That's an x-axis. That's the y-axis. This is the positive x-axis. That's the negative x-axis. This is the positive y-axis. And this is the negative y-axis. In Quadrant 1, both x and y are positive. That's positive, that's positive. In Quadrant 1, both x and y are positive. In Quadrant 1, both x and y are positive. In Quadrant 2, x is negative here. In Quadrant 2, x is negative. But y is positive. In Quadrant 2, x is negative. But y is positive. Here y is positive 1, 2, 3, 4. X is negative 1, 2, 3, 4. So in Quadrant 2, x is negative. Y is positive. In Quadrant 3, x is negative. Y is also negative. In Quadrant 3, x is negative. Y is also negative. In Quadrant 4 is here. X is positive. Y is negative. In Quadrant 4, x is positive. Y is negative. And since r equal to square root of x squared plus y squared, r is always positive in all 4 quadrants. R is always positive in all 4 quadrants. Since r is square root of x squared plus y squared, r is always positive in all 4 quadrants. So r is positive everywhere. R is positive everywhere. R is positive everywhere. Next, let me show you the signs of sine function in these 4 quadrants. So sine theta is always y over r. In Quadrant 1, y over r, positive number over positive number is positive. In Quadrant 2, y over r, positive number over positive number is positive. In Quadrant 3, y over r, negative number over positive number is negative. In Quadrant 4, y over r, negative number over positive number is negative. So sine function is positive in Quadrant 1 and Quadrant 2, negative in Quadrant 3 and Quadrant 4. It's sine function. Next, let's look at cosine function. We know that cosine theta is x over r. Cosine is x over r. In Quadrant 1, x is positive, r is positive. X over r is positive number over positive number, which is positive. So cosine function in Quadrant 1 is positive. How about Quadrant 2? In Quadrant 2, x over r. X is negative, y is positive, r is positive. X over r is negative. Negative number over positive number is negative. So cosine function in quadrant 2 is negative. In quadrant 3, cosine is s over r. Negative number over positive number is negative. Negative number over positive number is negative. So cosine function in quadrant 3 is negative. In quadrant 4, s is positive, r is positive. So x over r is positive. So cosine function in quadrant 4 is positive. That's cosine function. That's sines of cosine function. Next, let's look at the sines of tangent function. Tangent theta is always x over y. Tangent is s over y. In quadrant 1, s is positive, y is positive. So tangent is y over x. In quadrant 1, s is positive, y is positive. Y over x is positive number over positive number, which is positive. So tangent is positive in quadrant 1. In quadrant 2, s is negative, y is positive. So y over x is positive number over negative number, which is negative. So tangent is negative in quadrant 2. In quadrant 3, s is negative, y is negative. Tangent is y over x. Negative number over negative number is positive. In quadrant 4, s is positive, y is negative. We have y over x. Negative number over positive number is negative. So that's the sines of sine, cosine, and tangent. Sine function is positive in quadrant 1, quadrant 2. Negative in quadrant 3, quadrant 4. Cosine is positive in quadrant 1, quadrant 4. Negative in quadrant 2 and quadrant 3. Tangent is positive in quadrant 1 and quadrant 3. Negative in quadrant 2 and quadrant 4. And since cotangent is the reciprocal of tangent, their sign must be exactly the same. So tangent and cotangent, they have exactly the same signs. Tangent and cotangent have exactly the same signs in these 4 quadrants. And since cosine and secant, they are reciprocals of each other. So cosine and secant, they have exactly the same signs in these 4 quadrants. So for cosine and secant, they have exactly the same signs in these 4 quadrants. And since sine and cosecant, they are reciprocals of each other, which means they have the same signs in these 4 quadrants. So sine and cosecant, they have exactly the same signs in the coordinate plane. That's the signs of 6 trigonometric functions in the coordinate plane. Memorize this table. Memorize this table. That's the signs of these 6 trigonometric functions in the coordinate plane. Next, let me introduce reference angles. For any angle theta in the coordinate plane, its reference angle is the acute angle between its terminal side and the x-axis. For example, let theta be an angle in the coordinate plane in a standard position. So that's its initial side. Assume its terminal side is here. This is angle theta. Assume this is angle theta here. That's its initial side. That's its terminal side. Its reference angle is an acute angle between its terminal side and the x-axis. That's its reference angle. That's the reference angle of angle theta. In general, we use theta bar to represent the reference angle of angle theta. Note, in general, the reference angle of angle theta is denoted by theta bar. So in general, we use theta bar to represent the reference angle of angle theta. Next, let me show you reference angles in different cases. First of all, theta, it could be an angle in the first quadrant. Or it could be an angle in the second quadrant. Or it could be an angle in the third quadrant. There are 4 possibilities. Theta could be an angle in any quadrants, Theta could be an angle in the third quadrant. Or it could be an angle in the fourth quadrant. There are four possibilities. Theta could be an angle in any quadrant. Theta could be an angle in any quadrants. So there are four possibilities. Theta could be in the first quadrant, second quadrant, third quadrant, or the fourth quadrant. Next, let me try to find reference angles in each case. In the first case, if theta is an angle in the first quadrant, that's the terminal side. That's its terminal side. That's its terminal side. Its reference angle is an angle between the terminal side and the x-axis. That's the reference angle. You can see that the reference angle and angle theta they are exactly the same. So if theta belongs to quadrant 1, its reference angle is the same as angle theta itself. If theta belongs to quadrant 1, its reference angle is the same as angle itself. Now, case 2. If theta belongs to quadrant 2, how can we find its reference angle? In quadrant 2, that's its terminal side. That's the x-axis. The reference angle is the Q angle between its terminal side and the x-axis. This is the reference angle. This is theta bar. How can we find theta bar here? We know this angle here is 0 degree. 90 degrees is here. 180 is here. We know that theta plus theta bar is 180. Theta plus theta bar is 180, which means the reference angle can be written as 180 minus theta. The reference angle here is 180 minus theta. Reference angle is angle between theta and 180. So take 180 minus theta, we can find the reference angle. Use larger angle minus smaller angle. We get the reference angle here. So if angle theta lies in quadrant 2, its reference angle is 180 minus angle itself. So if angle theta lies in quadrant 2, its reference angle is 180 minus theta. And sometimes, in radian measure, 180 can be written as pi. If it's in degree measure, we use 180 minus theta. But if it's in radian measure, we use pi minus theta. That's how we find reference angle in the second quadrant. So for reference angle in the second quadrant, we use 180 minus theta or pi minus theta. Next, if theta lies in the third quadrant, that's its initial side. That's its terminal side. The reference angle is the Q angle between the terminal side and the x-axis. This is the reference angle. This angle here is angle theta. This is angle theta. This is reference angle in the third quadrant. Now, how can we find a reference angle here? We know this angle here is 0 degree, 90 degree, 180 degrees here. The reference angle here is an angle between theta and 180. Here, the reference angle is an angle between theta and 180. So, the reference angle can be found by using theta minus 180. Use larger minus smaller. Larger angle minus smaller angle, again the reference angle. Reference angle is always positive. Reference angle is always positive. So we must use larger number minus smaller number. So it's theta minus 180. So if theta belongs to quadrant 3, its reference angle is always theta minus 180. Sometimes if you use radian measure, it can be written as theta minus pi. If we use radian measure, sometimes we write theta minus pi. Now, if angle theta lies in quadrant 4. If angle theta lies in quadrant 4, then how can we find the reference angle? For angle theta, that's the initial side. That's the terminal side. The reference angle is an angle between the terminal side and the x-axis. This is a reference angle. The reference angle is the angle between terminal side and the x-axis. This is a reference angle. Now, how can we find a reference angle? How can we find a reference angle here? We know that 0 degree is here, 90 is here, 180 is here, 270 degrees is here. 270 plus 90 is 360. 360 degrees here. So the reference angle is an angle between 360 and theta. The reference angle is an angle between 360 and theta. So in order to find a reference angle, we use larger number minus smaller number. Take 360 minus theta. Reference angle is the difference between 360 and theta. If it's in radian measure, sometimes we write 2 pi minus theta. 360 is the same as 2 pi in radian measure. So that's how we find reference angles in different quadrants. If theta belongs to quadrant 1, reference angle equal to theta itself. If theta belongs to quadrant 2, reference angle is 180 minus theta. If theta belongs to quadrant 3, reference angle is theta minus 180. And if theta belongs to quadrant 4, its reference angle is 360 minus theta. Next, let me show you some computations about reference angles first. Then I'll explain what does reference angles mean and what's the purpose of learning reference angle. Let's look at this example first. Find the reference angle for each of the following angles. First angle, 120 degrees. How can we find the reference angle? In order to find a reference angle, let's first of all determine its quadrants first. What quadrant does this angle lie? We know that there are 4 quadrants. 0 degree is here, 90 degrees is here, 180 is here, 270 is here, and 360 go back to 0. We measure the angle counterclockwise. 0 is here, 90 is here, 180 is here, 270 is here, and 360 is here. 120 is somewhere between 90 and 180. So 120 degrees belongs to quadrant 2. It lies in quadrant 2. For angle lies in quadrant 2, its reference angle is 180 minus angle itself. For angle in quadrant 2, its reference angle is 180 minus angle itself. So its reference angle is 180 minus the angle itself. I guess 60 degrees. That's a reference angle of 120 degrees. So that's a reference angle of this 120 degree angle. Next example. The angle is 225 degrees. How can we find its reference angle? First step, determine its quadrant. 225 degrees lies in quadrant 3. 225 degree angle lies in quadrant 3. If the angle lies in quadrant 3, its reference angle for angle lies in quadrant 3, its reference angle is always the angle itself minus 180. If angle lies in quadrant 3, its reference angle is always the angle itself minus 180. So the reference angle of 225 is an angle itself minus 180. That's its reference angle. So its reference angle is a 45 degree angle. Next example, 300 degree. How can we find the reference angle of this angle? First step, determine the quadrant. What quadrant does this angle lie? We know that 300 is between 270 and 360. So this angle lies in quadrant 4. This angle lies in quadrant 4. For angle lies in quadrant 4, its reference angle is always 360 minus the angle itself. If angle lies in quadrant 4, its reference angle is always 360 minus the angle itself. So its reference angle is 360 minus the angle itself, which is 60. That's the reference angle of this 300 degree angle. Next example, 45 degree. What's the reference angle of this angle? First of all, determine its quadrant. 45 degree angle lies in quadrant 1, is between 0 and 90. This angle lies in quadrant 1. If angle lies in quadrant 1, its reference angle is the angle itself. If angle lies in quadrant 1, its reference angle is the angle itself. So its reference angle is 45 degree angle. If angle lies in quadrant 1, its reference angle is the angle itself. Next example, 390 degree. If the angle is more than 360, we must find its coterminal angle first. Find its coterminal angle between 0 and 360. So we take 390 minus 360. We get 30 degree angle. That's the coterminal angle of 390 degree. And we know that 30 degree angle lies in the first quadrant. For angle lies in the first quadrant, its reference angle is the angle itself. If angle lies in the first quadrant, its reference angle is the angle itself. Next example, 495 degree. If the angle is more than 360, we must find the coterminal angle between 0 and 360 first. So we first of all take 495 minus 360. We get 135 degree. That's the coterminal angle of this angle. And here we can see that 135 degree is between 90 and 180. So 135 degree angle lies in the second quadrant. If the angle lies in the second quadrant, its reference angle is always 180 minus this angle. And 180 minus 135 is 45 degree. That's its reference angle. Next example, 960 degree. Again, if the angle is more than 360, we must find the coterminal angle between 0 and 360 first. So, I first of all take 960 minus 360. I get 600 degree. It's still more than 360. Let's keep subtracting. 600 minus 360 is 240 degree. That's the coterminal angle between 0 and 360. Next, let's find the reference angle. 240 degree is between 180 and 270. So 240 degree angle lies in quadrant 3. If the angle lies in quadrant 3, its reference angle, here 240 degree angle lies in quadrant 3. If the angle lies in quadrant 3, its reference angle is an angle itself, 240 degree minus 180. And 240 degree minus 180 degree is 60 degree. That's its reference angle. Next example, 1410 degree. How can we find the reference angle? If the angle is more than 360, we must find the coterminal angle first. Find the coterminal angle between 0 and 360. So take 1410 degree minus 360. I get 1050 degree. It's still more than 360, so keep subtracting. Take 1050 minus 360. It's 690. That's still more than 360. Keep subtracting. Take 690 minus 360. We get 330. This angle is between 0 and 360, so that's fine. Now, based on this angle, let's try to find the reference angle. 330 is between 270 and 360, so it lies in quadrant 4. If the angle lies in quadrant 4, its reference angle is 360 minus 330. That's 30 degree. That's how we find the reference angle. Next example. How about negative 315 degree? How about negative 315 degree? If the angle is negative, again, we try to find the coterminal angle between 0 and 360. If the angle is negative, we try to find the coterminal angle between 0 and 360 first, and then find the reference angle. If the angle is negative, keep adding 360 to make it positive. Negative 315 plus 360, that's 45 degree. That's its reference angle. That's its coterminal angle between 0 and 360. And here we can see that 45 degree angle lies in quadrant 1. If the angle lies in quadrant 1, its reference angle is this angle itself. Next example, negative 240 degree. How can we find the reference angle? If the angle is negative, let's find the coterminal angle first. Find the coterminal angle between 0 and 360. If the angle is negative, keep adding 360 to make it positive. If I add 360 to this angle, I get 120 degree. That's its coterminal angle. And we know that 120 degree angle lies in quadrant 2. For angle lies in quadrant 2, its reference angle is 180 minus the angle itself. 180 minus 120 is 60 degree. Next example, how about negative 510? How can we find the reference angle? If the angle is negative, try to find the coterminal angle between 0 and 360 first. So for its coterminal angle, keep adding 360 until it becomes positive. Keep adding 360 until it becomes positive. Negative 510 plus 360 is negative 150. It's still negative. Keep adding 360 to make it positive. Negative 150 plus 360 is 210. And we know that 210 degree is between 180 and 270. So this angle 210 lies in quadrant 3. If the angle lies in quadrant 3, its reference angle is the angle itself minus 180, which is 30 degree. That's the reference angle of this angle. Next example, negative 765 degree. How can we find the reference angle? If the angle is negative, Keep adding 360 until it becomes positive. Negative 765 plus 360 is negative 405 degree. It's still negative. Keep adding 360 until it becomes positive. That's negative 45 degree. Again, it's still negative. Keep adding 360 until it becomes positive. I guess 315. Now this angle is between 0 and 360. So that's the coterminal angle of this angle. That's the coterminal angle of this angle between 0 and 360. Next, determine the quadrant. 315 degree angle is between 270 and 360. So 315 degree lies in quadrant 4. If an angle lies in quadrant 4, its reference angle is 360 minus the angle itself, which is 45 degree angle. So that's the reference angle of this angle. Next, how about pi over 3? Sometimes an angle may be given in radian measure. What quadrant does pi over 3 locate? So 0 degree in radian measure is 0. 90 degree in radian measure is pi over 2. 180 degree in radian measure is pi. 270 degree in radian measure is 3 pi over 2. And 360 degree in radian measure is 2 pi. What quadrant does pi over 3 lies? Pi over 2 can be rewritten as 3 pi over 6. And we know that pi over 3 is 2 pi over 6. Here we can see that 2 pi over 6 is between 0 and 3 pi over 6. So pi over 3 lies in quadrant 1. Pi over 3 lies in quadrant 1. If an angle lies in quadrant 1, its reference angle is an angle itself. Pi over 3 lies in quadrant 1, so its reference angle is an angle itself. Next, how about 5 pi over 6? How about 5 pi over 6? We know that pi over 2 can be rewritten as 3 pi over 6. And pi by itself can be rewritten as 6 pi over 6. So you can see that 5 pi over 6 is between 3 pi over 6 and 6 pi over 6. Make the denominator the same and then compare the angle. You can see that 5 pi over 6 is between 3 pi over 6 and 6 pi over 6. So 5 pi over 6 lies in quadrant 2. If an angle lies in quadrant 2, its reference angle is always, if an angle lies in quadrant 2, its reference angle is always, in radian measure is pi minus the angle itself. If an angle lies in quadrant 2, its reference angle is pi minus the angle itself. In radian measure, we use pi. So use pi minus the angle itself. We know that pi can be rewritten as 6 pi over 6. 6 pi over 6 minus 5 pi over 6 is pi over 6. That's its reference angle. So the reference angle of 5 pi over 6 is pi over 6. Next example, 13 pi over 4. What quadrant does this angle locate? What quadrant does this angle lie? Here, 13 pi over 6 is more than 2 pi. 2 pi is a pi over 13 pi over 4 is more than 2 pi. 2 pi is a pi over 2 pi is a pi over 4. We can see that 13 pi over 4 is more than 2 pi. So in order to find a reference angle, we must find a coterminal angle between 0 and 2 pi first. In order to find a reference angle, we must find a coterminal angle between 0 and 2 pi first. If angle is more than 2 pi, keep subtracting by 2 pi. Take 13 pi over 4 minus 2 pi. Here 2 pi is 8 pi over 4. 13 pi over 4 minus 8 pi over 4 is 5 pi over 4. Now, what quadrant does 5 pi over 4 lie? What quadrant does 5 pi over 4 lie? Let's try to make the denominator to be 4. Pi over 2 can be written as 2 pi over 4. Pi by itself can be written as 4 pi over 4. 3 pi over 2 can be written as 6 pi over 4. And here we can see that 5 pi over 4 is between 4 pi over 4 and 6 pi over 4. So this angle lies in quadrant 3. 5 pi over 4 lies in quadrant 3. If an angle lies in quadrant 3, its reference angle is the angle itself minus pi. If angle lies in quadrant 3, the reference angle is the angle itself minus pi. So for the reference angle, we use 5 pi over 4 minus pi. And we know that pi is 4 pi over 4. 5 pi over 4 minus 4 pi over 4 is pi over 4. That's the reference angle of this angle. That's the reference angle of this angle. Next example. How about 17 pi over 3? How about 17 pi over 3? First of all, it looks like this angle is more than 2 pi. If I write 2 pi as a fraction over 3, it can be written as 6 pi over 3. And here we can see that 17 pi over 3 is more than 2 pi. It's more than 6 pi over 3. If an angle is more than 2 pi, we try to find the coterminal angle between 0 and 2 pi. So let's find a coterminal angle between 0 and 2 pi first. Keep subtracting this angle by 2 pi until it's between 0 and 2 pi. So take 17 pi over 3 minus 2 pi. What do we get? 2 pi is 6 pi over 3. 17 pi over 3 minus 6 pi over 3 is 11 pi over 3. Again, it's still more than 2 pi. Keep subtracting. Take 11 pi over 3 minus 2 pi. 2 pi is 6 pi over 3. 11 pi over 3 minus 6 pi over 3 is 5 pi over 3. And 5 pi over 3 is less than 6 pi over 3. So this angle is between 0 and 2 pi. That's okay. Next, find a reference angle based on this angle, 5 pi over 3. What quadrant does 5 pi over 3 lie? For 3 and 2, the least common denominator is 6. So try to put this over 6. Pi over 2 can be written as 3 pi over 6. Pi by itself can be written as 6 pi over 6. 3 pi over 2 can be written as 9 pi over 6. And 2 pi can be written as 12 pi over 6. 5 pi over 3 is the same as 10 pi over 6. Multiply top and bottom by 2. We can see that 10 pi over 6 is between 9 pi over 6 and 12 pi over 6. So this angle lies in quadrant 4. 10 pi over 6 lies in quadrant 4. Which means 5 pi over 3 lies in quadrant 4. If an angle lies in quadrant 4, its reference angle is 2 pi minus the angle itself. If an angle lies in quadrant 4, its reference angle is 2 pi minus the angle itself. So take 2 pi minus 5 pi over 3. 2 pi can be rewritten as 6 pi over 3. 6 pi over 3 minus 5 pi over 3 is pi over 3. That's the reference angle of this angle. That's the reference angle of this angle, 17 pi over 3. Next example. How about negative 11 pi over 6? If an angle is negative, we try to find the coterminal angle between 0 and 2 pi first. Here, 2 pi, if I try to rewrite 2 pi as a fraction over 6, 2 pi can be rewritten as 12 pi over 6. So take negative 11 pi over 6 plus 2 pi. Negative 11 pi over 6 plus 12 pi over 6 is pi over 6. This angle pi over 6 lies in quadrant 1. For any angle lies in quadrant 1, its reference angle is the same as angle itself. So the reference angle is pi over 6. Next example. How about negative 13 pi over 4? Again, this angle is negative. If the angle is negative, we try to find the coterminal angle between 0 and 2 pi first. How much is 2 pi? If I write 2 pi as a fraction over 4, 2 pi can be rewritten as a pi over 4. Then if the angle is negative, keep adding 2 pi until it becomes positive. Take negative 13 pi over 4 plus 2 pi. That's the same as negative 13 pi over 4 plus a pi over 4. That's negative 5 pi over 4. This angle is still negative, so keep adding 2 pi until it becomes positive. Take negative 5 pi over 4 plus 2 pi. Again, 2 pi is a pi over 4. Negative 5 pi over 4 plus a pi over 4 is 3 pi over 4. Now this angle is between 0 and 2 pi. Next, find the reference angle based on this angle. What quadrant does 3 pi over 4 lie? What quadrant does 3 pi over 4 lie? Let's first of all rewrite everything as a fraction over 4 and then compare the angles. Pi over 2 can be rewritten as 2 pi over 4. Pi can be rewritten as 4 pi over 4. 3 pi over 2 can be rewritten as 6 pi over 4. And 2 pi is 8 pi over 4. We have 3 pi over 4 here. We can see that 3 pi over 4 is between 2 pi over 4 and 4 pi over 4. So this angle 3 pi over 4 lies in quadrant 2. So 3 pi over 4 lies in quadrant 4. So 3 pi over 4 lies in quadrant 2. 3 pi over 4 lies in quadrant 2. For any angle lies in quadrant 2, its reference angle is pi minus the angle itself. For any angle lies in quadrant 4, that lies in quadrant 2, its reference angle is pi minus the angle itself. And we know that pi is 4 pi over 4. 4 pi over 4 minus 3 pi over 4 is pi over 4. That's the reference angle of this angle. Next, let me show you more about special trigonometry values. For example, how can we evaluate sine of 120 degree, cosine of 225 degree, or tangent of 330 degree? Those angles are known as special values on the table of special trigonometry values. How can we evaluate these values? In order to evaluate these values, we can try to use reference angle. But why reference angle? Let's compare the reference angle and actual angle. Let's compare the reference angle and actual angle. If angle theta lies in quadrant 1, its reference angle is an angle itself. That's its reference angle. If angle theta lies in quadrant 1, the reference angle is the same as angle itself. If we draw the triangle based on this angle and its reference angle, we can see that these two triangles, they are similar triangles. These two triangles, they are similar. That's for angle lies in quadrant 1. If angle lies in quadrant 2, if angle theta lies in quadrant 2, it looks like this. Its reference angle. If angle lies in quadrant 2, that's its reference angle, theta bar. If we draw a triangle for angles theta and theta bar, what do we get? If we draw a triangle based on theta, we get this triangle. If we draw a triangle based on theta bar, we get the same triangle. These two triangles, they are similar triangles. Again, if angle theta lies in quadrant 3, if angle theta lies in quadrant 3, that's angle theta. And its reference angle looks like this. That's its reference angle in quadrant 3. This is its reference angle in quadrant 3. If we draw a triangle for angle theta, it looks like this. And if we draw a triangle based on its reference angle, it looks similar. They are similar triangles. Again, if angle theta lies in quadrant 4, if angle theta lies in quadrant 4, that's angle theta. And its reference angle looks like this. That's its reference angle, theta bar. If we draw a triangle for theta and theta bar, that's a triangle based on theta, based on angle theta. And that's a triangle based on theta bar. We can see that they are similar triangles. So in all 4 cases, if we draw a triangle based on angles theta and theta bar, we all get similar triangles, which means their trigonometry values must be exactly the same. They have the same opposite, same adjacent, same hypotenuse. All 6 trigonometry values must be the same. The only difference is the plus minus sign. The trigonometry values must be exactly the same. The only difference is in the plus minus sign, because reference angle is always a cube angle. All its trigonometry values are positive. The reference angle is a cube angle. All its trigonometry values are positive. But this theta itself lies in different quadrants. And we know that trigonometry functions in different quadrants has different plus minus sign. So for reference angle theta bar and theta, all their trigonometry values are exactly the same. The only difference is the plus minus sign. And finding a trigonometry values using reference angle is much easier because it's a cube angle. So using reference angle to find special trigonometry values is much easier than using the angle itself, angle theta itself. Next, let me show you some example about how to using reference angle to find special trigonometry values. Next, let's look at some examples. Evaluate each of the following trigonometry values. First example, how can we evaluate sine of 120 degrees? We know that 120 degrees is an angle lies in quadrant 2. And for angle in quadrant 2, its reference angle is 180 minus 120. 180 minus 120 is 60 degrees. So that's its reference angle. That's its reference angle. That means sine of 120 has exactly the same value as sine of 60. The only difference is the plus minus sign. Their values are exactly the same. Since 60 is a reference angle, their values is exactly the same. The only difference is the plus minus sign. Is it positive or negative? And we know that sine function in quadrant 2 is positive. Sine function in quadrant 2 is positive. So now equal to positive sine 60. And what's sine 60? Sine 60 is one of the special values. Sine 60 is radical 3 over 2. So the answer for sine of 120 degree is radical 3 over 2. That's the answer to sine of 120. Next, how about cosine of 225 degree angle? 225 is the angle lies in quadrant 3. Is an angle lies in quadrant 3. If an angle lies in quadrant 3, its reference angle is the angle itself minus 180, which is a 45 degree angle. Since that's the reference angle, cosine 225 has exactly the same value as cosine 45 degree angle. The only difference is the plus minus sign. Their values are exactly the same. The only difference is the plus minus sign. Now, this angle lies in quadrant 3. Cosine function in quadrant 3, 1, 2, 3. Cosine function in quadrant 3 is negative. So cosine 225 is negative cosine 45. Then how much is cosine 45? Cosine 45, that's a special value. Cosine 45 is 1 over radical 2. Cosine 45 is 1 over radical 2. If we try to rationalize the denominator, 1 over radical 2, I can multiply top and bottom by radical 2. It can be rewritten as radical 2 over 2. That's cosine of 45 degree angle. It's either 1 over radical 2, or you can write it as radical 2 over 2. Either way is okay. It's negative. Don't forget negative sign. It's negative. Next example. How about tangent 330? First of all, 330 degree angle lies in quadrant 4. 330 degree angle lies in quadrant 4. For angle lies in quadrant 4, its reference angle is 360 minus the angle itself. For angle lies in quadrant 4, its reference angle is the angle is 360 minus the angle. And here we can see that 360 minus 330 is 30 degree. That's its reference angle, which means tangent of 330 is the same as tangent 30. Their value is exactly the same. The only difference is the plus minus sign. The only difference is the plus minus sign. Now, this angle lies in quadrant 4. We know that tangent in quadrant 4, 1, 2, 3, 4. Tangent in quadrant 4 is negative. Tangent in quadrant 4 is negative. So tangent of 330 is negative tangent 30. How much is tangent 30? Tangent 30 is a special trigonometry values. That's 1 over radical 3. Tangent 30 is a special trigonometry values. That's 1 over radical 3. So we get negative 1 over radical 3. Sometimes we need to rationalize the denominator. If we rationalize the denominator, it can be written as negative 1 over radical 3 times radical 3 over radical 3. That's negative radical 3 over 3. So that's tangent of 330. We can write it as negative 1 over radical 3 or negative radical 3 over 3. Either way is okay. Next example. How about secant of 405? How about secant of 405 degree? Now, 405 degree angle is more than a cycle. It's more than 360. 405 degree is more than one cycle. If an angle is more than one cycle, subtract by 360. If angle is more than 1 cycle, subtract by 360. Find the coterminal angle between 0 and 360 first. If I take 405 minus 360, I get 45 degrees. Coterminal angle terminates at exactly the same position, so their trigonometry values is exactly the same, including the plus minus sign is exactly the same. Coterminal angle ends in the same position. Their trigonometry values are exactly the same, including plus minus sign. They are exactly the same. And what's secant 45? Secant 45 is a special trigonometry values. Secant 45 is radical 2. That's an answer to secant 405. Next example. How about cosecant 480? How about cosecant 480? 480 degree angle is more than 1 cycle. If an angle is more than 1 cycle, subtract this angle by 360 degrees. Find the coterminal angle between 0 and 360 first. So here, 480 minus 360 is 120. So cosecant of 480 is the same as cosecant of 120. Coterminal angles ends at the same position, so their values are exactly the same, including plus minus sign. Their values are exactly the same. Now, a 120 degree angle is not a acute angle. We need to find its reference angle. We know that 120 degree angle lies in quadrant 2. So for its reference angle, we use 180 degree angle minus angle itself. I get 60 degree angle. So that's the same as cosecant 60. Since the reference angle of 120 degree angle is 60 degree, cosecant of 120 is exactly the same as cosecant 60. The only difference is the plus minus sign. And we know that cosecant in the second quadrant is positive. This angle lies in quadrant 2. Cosecant in the second quadrant is positive. So you get positive cosecant 60. And cosecant 60 is a special trigonometry values. Cosecant 60 is 2 over radical 3. Cosecant 60 is 2 over radical 3. Sometimes we may want to rationalize the denominator. If we rationalize the denominator, we multiply top and bottom by square root of 3. We get 2 radical 3 over 3. So the answer could be either 2 over radical 3 or 2 radical 3 over 3. Either way is okay. Next, how about cotangent 930? Again, if an angle is more than a cycle, it's more than 360, let's find coterminal angle between 0 and 360 first. If an angle is more than 1 cycle, let's find coterminal angle between 0 and 360 first. So here I take 930 minus 360. 930 minus 360 is 570 degree. Again, 470 is still more than 1 cycle. 470 is still more than 1 cycle. Keep subtracting by 360. 570 minus 360 is 210. And 210 is between 0 and 360. Since 210 and 210 is the coterminal angle of 930, their trigonometry values are exactly the same, including the sine. They end in the same position. Their trigonometry values are exactly the same, including the sine is also the same. So cotangent 210 is exactly the same as cotangent 930. Now, for 210, this angle is not a acute angle. Let's find the reference angle first. 210 lies in quadrant 3. 210 lies in quadrant 3. For angle in quadrant 3, its reference angle is the angle itself, minus 180. For angle lies in quadrant 3, its reference angle is the angle itself, minus 180, which is 30 degrees. So cotangent 210 is the same as cotangent 30. When we use reference angle, be very, very careful. Check the sign. The sign may be changed. When we use coterminal angle, don't worry about the sign. It looks exactly the same. But when we use reference angle, be very, very careful. The sign may be changed. Now, cotangent in quadrant 3 is what? Cotangent in quadrant 3. Quadrant 1, quadrant 2, quadrant 3. Cotangent in quadrant 3 is positive. So you get positive cotangent 30. Then how much is cotangent 30? Cotangent 30, that's one of the special trigonometry values. Cotangent 30 is radical 3. It's radical 3. So that's an answer. That's cotangent of 930. I get radical 3. Next, how about sine of negative 45? How about sine of negative 45 degree? If an angle is negative, try to find coterminal angle. Try to find a positive coterminal angle first. If an angle is negative, we can evaluate it directly. Let's try to find a positive coterminal angle first. If I take negative 45 plus 360, I get 315. If I take negative 45 plus 360, I get 315. And 315, this angle lies in quadrant 4. This angle lies in quadrant 4. For any angle lies in quadrant 4, its reference angle is 360 minus the angle itself, which is 45 degrees. Since that's a reference angle, sine of 315 is exactly the same as sine of 45. When we use reference angle, the positive negative sign may be changed. They are exactly the same, but they may have different positive negative sign. This angle lies in quadrant 4. Sine function in quadrant 4 is negative. Quadrant 1, quadrant 2, quadrant 3, quadrant 4. Sine function in quadrant 4 is negative. So I get negative sine 45. 45 degrees is a special angle. Sine 45 is 1 over radical 2. Carry negative sign. We get 1 over radical 2. If we rationalize the denominator, it can be written as negative radical 2 over 2. So either way is okay. You can write it as negative 1 over radical 2 or negative radical 2 over 2. They are exactly the same. Next example. How about cosine of negative 600? Again, when we see a negative angle, we try to find a positive coterminal angle first. If I take negative 600 plus 360, negative 600 plus 360, I get negative 240. It's still negative. Keep adding 360 until it become positive. Keep adding 360 until it becomes positive. Negative 240 plus 360 is 120. We get cosine of 120. 120 degree angle lies in quadrant 2. For any angle lies in quadrant 2, its reference angle is 180 minus the angle itself, which is 60 degree. So for 120 degree angle, its reference angle is 60 degree. Since that's a reference angle, its value looks exactly the same. The only difference is the plus minus sign. The only difference is the plus or minus sign. And we know that 120-degree angle lies in quadrant 2. Cosine function in quadrant 2. Cosine function in quadrant 2 is negative. So I get negative cosine of 60. Cosine of 60, that's a special trigonometric values. Cosine 60 is half. Cosine 60 is half. So cosine of negative 600-degree angle is negative half. Next, what about tangent of negative 930? This is a negative angle. When we have a negative angle, try to find a positive coterminal angle first. So keep adding 360 until it becomes positive. Keep adding 360 until it becomes positive. Negative 930 plus 360 is negative 570. It's still negative. Keep adding 360. Negative 570 plus 360 is negative 210. Still negative. Keep adding 360 until it becomes positive. Negative 210 plus 360 is 150. 150-degree angle lies in quadrant 2. If an angle lies in quadrant 2, its reference angle is 180 minus the angle itself. I get 30. That's a reference angle. Since 30 is a reference angle, cosine of 150 is exactly the tangent of 150 is exactly the same as tangent of 30. The only difference is the plus or minus sign. And the only difference is the plus or minus sign. And this angle 150 lies in quadrant 2. We know that tangent in quadrant 2 is negative. We get negative tangent of 30. And tangent of 30 is a special trigonometry values. Tangent of 30 is 1 over radical 3. So this is negative 1 over radical 3. Or you can rationalize the denominator. It's not necessary. So tangent of 30 is 1 over radical 3. It's negative. So carry negative sign. Next example. Cotangent of negative 495. What's cotangent of negative 495? If an angle is negative, let's try to find a positive coterminal angle first. Keep adding 360 until it becomes positive. Negative 495 plus 360 is negative 135. It's still negative. If an angle is negative, keep adding 360 until it becomes positive. Negative 135 plus 360 is 225. That's a positive coterminal angle. And we know that this angle, 225, lies in quadrant 3. For angle lies in quadrant 3, its reference angle is the angle itself, minus 180. 225 minus 180 is 45 degree. So the reference angle is 45 degree angle. That means cotangent 225 is exactly the same as cotangent 45. The only difference is the plus minus sign. The only difference is the plus minus sign. Now let's check the plus minus sign. 225 degree angle lies in quadrant 3, and cotangent in quadrant 3 is positive. Quadrant 1, quadrant 2, quadrant 3. Cotangent in quadrant 3 is positive. So you get positive cotangent 45. And cotangent 45 is a special trigonometry values. Cotangent 45 is 1. Cotangent 45 is 1. The final answer is 1. Next. How about sine of 990 degree? How about sine of 990 degree? If the angle is more than 360, let's find the coterminal angle between 0 and 360 first. So I take 990 minus 360. Take 990 minus 360. I get 630 degree. Again, this angle is still more than 360. Take 630 minus 360. Take 630 minus 360. I get 270 degree. This angle is between 0 and 360. That's okay. Now determine the quadrant. 270 degree angle. 0 is here. 90 is here. 180 is here. 270 degrees is here. It doesn't lie in any quadrant. 270 degree angle. It doesn't lie in any quadrant. Now how can we find its value? 270 degree angle is also one of the special trigonometry values. 270 degree angle is also one of the special trigonometry values. Sine in this table, sine of 270 is -1. Sine of 270 is -1. That's also one of the special trigonometry values. 0, 90, 180, 270. That's also one of the special trigonometry values. Sine of 270 is -1. Here we don't need to find a reference angle. Since this angle doesn't lie in any quadrant, we cannot find its reference angle. So leave it the way it is. Sine of 270 on the table is -1. Next, how about cosine of -540? How about cosine of -540? If the angle is negative, let's find its positive coterminal angle first. -540 plus 360 is -180. It's still negative. Keep adding 360 until it becomes positive. Cosine of -180. -180 plus 360 is positive 180. -180 plus 360 is positive 180. Again, 180 is one of the special angles. 180 doesn't lie in any quadrant. It's here. It doesn't lie in any quadrant. But there's a special trigonometry values. Cosine 180 is -1. Next, how about tangent of 5 pi over 6? How about tangent of 5 pi over 6? Sometimes the angle may be given in radian measure. So for tangent of 5 pi over 6, we can try to convert this angle to degree measure. It may be a little easier. Instead of using radian measure, let's try to convert this angle to degree measure. It may be a little easier. If I convert this angle to degree measure, 5 pi over 6, take 5 pi over 6 times 180 degree over pi. Cancel pi. I get 5 times 180 degree over 6. 180 over 6 is 30. 30 times 5 is 150. So we get tension of 150. 150-degree angle lies in quadrant 2, and its reference angle is, for angle in quadrant 2, its reference angle is 180 minus the angle itself. That's 30 degrees. That's a reference angle, so the value is exactly the same. The only difference is the plus or minus sign. And we know that this angle lies in quadrant 2. Tension in quadrant 2. Tension in quadrant 2 is negative. I get negative tension 30, and tension 30 is a special trigonometry values. Tension 30 is 1 over radical 3. So I get negative 1 over radical 3. Or if we rationalize the denominator, it can be written as negative radical 3 over 3. Next, how about secant of 5 pi over 4? In general, when we see an angle in radian measure, we can try to change it to degree measure first. That's a little easier. Using degree measure is a little easier. Take 5 pi over 4 times 180 over pi. Cancel pi from top and bottom. We get 5 times 180 degree over 4. Here, let's do division first. If you take 180 divided by 4, I get 45. 45 times 5 is 225. So secant 5 pi over 4 is 225 degree. Secant of 225 degree. And we know that this angle, 225 degree angle, lies in quadrant 3. For angle lies in quadrant 3, its reference angle is the angle itself minus 180, which is 45 degree. So that's the reference angle. Since that's the reference angle, their value is exactly the same. The only difference is the plus or minus sign. The only difference is the plus or minus sign. And we know that secant in quadrant 3 is what? Secant in quadrant 3, quadrant 1, quadrant 2, quadrant 3, secant in quadrant 3 is negative. So secant of 225 is negative secant of 45. What's secant 45? Secant 45 is square root of 2. That's the final answer. Next, how about sine of 15 pi over 4? How about sine of 15 pi over 4? This angle is more than 2 pi. 5 pi over 4, 15 pi over 4 is more than 2 pi. We know that 2 pi, if I write it as a fraction over 4, that's 8 pi over 4. 15 pi over 4 is more than 2 pi. Let's first of all keep reducing the angle. Find its coterminal angle between 0 and 2 pi first. Find its coterminal angle between 0 and 2 pi first. Take 15 pi over 4 minus 2 pi. 2 pi is 8 pi over 4. I get 7 pi over 4. That's the coterminal angle. 7 pi over 4. Next, 7 pi over 4 is between 0 and 2 pi. It's less than 8 pi over 4. That's between 0 and 2 pi. That's okay. Next, we can try to change this angle to degree measure. That could be a little easier. Change this angle to degree measure could be a little easier. Next, take 7 pi over 4 times 180 over pi. cancel pi from top and bottom. We get 7 times 180 over 4. Next, let's do division first, and then multiply. 180 divided by 4 is 45 degrees. And 45 degree angle times 7 is 315 degrees. So 7 pi over 4 in degree measure is 315 degrees. And this angle, it lies in quadrant 4. 315 degree angle lies in quadrant 4. If an angle lies in quadrant 4, its reference angle is 360 degrees minus 315 degrees, which is 45 degrees. That's its reference angle. That's its reference angle. So their value is exactly the same. Since that's a reference angle, their value is exactly the same. The only difference is in the plus or minus sign. Now, this angle 315 lies in quadrant 4. Sine function in quadrant 4. Quadrant 1, quadrant 2, quadrant 3, quadrant 4. Sine function in quadrant 4 is negative. And sine 45 is a special value. In the table, we can see that sine 45 is 1 over radical 2. So the answer is negative 1 over radical 2. Or if we rationalize the denominator, that's negative radical 2 over 2. They are exactly the same. Either one is okay. Next. How about cosine of 16 pi over 3? How about cosine of 16 pi over 3? First of all, 16 pi over 3 is more than 2 pi. 16 pi over 3 is more than 2 pi. If we write 2 pi as a fraction over 3, I get 6 pi over 3. We can see that 16 pi over 3 is more than 2 pi. So I take 16 pi over 3 minus 2 pi. 2 pi is 6 pi over 3. 16 pi over 3 minus 6 pi over 3 is 10 pi over 3. So cosine 16 pi over 3 is the same as cosine 10 pi over 3. But 10 pi over 3 here is still more than 2 pi. 10 pi over 3 is still more than 2 pi. So keep subtracting. Take 10 pi over 3 minus 2 pi. We get 4 pi over 3. Because 2 pi is 6 pi over 3, I get 4 pi over 3. So cosine of 10 pi over 3 is exactly the same as cosine of 4 pi over 3. Next, we can try to change 4 pi over 3 to degree measure. This angle is between 0 and 2 pi. Next, try to change this angle to degree measure. 4 pi over 3, if I change it to degree measure, it can be written as 4 pi over 3 times 180 degree over pi. I can cancel pi from top and bottom. I get 4 times 180 degree over 3. Let's do division first. 180 over 3 is 60. 4 times 60 is 240 degree. So cosine of 4 pi over 3 is the same as cosine of 240 degree. Cosine of 4 pi over 3 is the same as cosine of 240 degree. And this angle, 240 degree angle, lies in quadrant 3. 240 degree angle lies in quadrant 3. If an angle lies in quadrant 3, its reference angle is the angle itself minus 180 degree angle, which is 60 degree. So cosine of 240 is exactly the same as cosine 60. But when we use reference angle, the sign may be different. The plus minus sign may be different. When we use reference angle, the plus minus sign may be different. Here, this angle 240 degree lies in quadrant 3. Cosine function in quadrant 3. Cosine function in quadrant 3. Quadrant 1, quadrant 2, quadrant 3. Cosine function in quadrant 3 is negative. So that's negative cosine 60. How much is cosine 60? Cosine 60 is a special value. Cosine 60 is 1 over 2. It's a half. So the final answer is negative 1 over 2. Next. How about tangent of negative 7 pi over 6? Again, if an angle is negative, let's find its positive coterminal angle first. If an angle is negative, let's find its positive coterminal angle first. If I try to write 2 pi as a fraction over 6, 2 pi can be rewritten as 12 pi over 6. And if an angle is negative, keep adding 2 pi until it becomes positive. Negative 7 pi over 6, if I plus 2 pi, 2 pi is 12 pi over 6. Negative 7 pi over 6 plus 12 pi over 6 is 5 pi over 6. Next is coterminal angle. And now this angle is positive. This angle is positive between 0 and 2 pi. To make it a little easier, we try to convert this angle to degree measure. Take 5 pi over 6 times 180 degree over pi. We can cancel pi from top and bottom. What's left is 5 times 180 over 6. We can do division first and then multiply. 180 divided by 6 is 30. 30 times 5 is 150. So tangent of 5 pi over 6 is the same as tangent of 150. A 150 degree angle lies in quadrant 2. If an angle lies in quadrant 2, its reference angle is always 180 minus the angle itself, which is 30 degree. So its reference angle is 30 degree angle. Since 30 is a reference angle, their value is exactly the same. We get tangent 30 here. The only difference is the plus minus sign. When we use reference angle, its value may be changed. Its plus minus sign may be changed. Its value is the same, but the plus minus sign may be different. Here, this angle, 150 degree angle, lies in quadrant 2. Tangent in quadrant 2 is negative. So again, negative tangent 30. Tangent 30 on the table is 1 over radical 3. So carry negative sign, I get negative 1 over radical 3. If we rationalize the denominator, it can be written as negative radical 3 over 3. So either way is okay. We can write it as negative 1 over radical 3 or negative radical 3 over 3. Next, how about secant of negative 8 pi over 3? How about secant of negative 8 pi over 3? First of all, if an angle is negative, let's try to find a positive coterminal angle first. If the angle here is negative, let's try to find a positive coterminal angle first. For 2 pi, if I put it over 3, if I write it as a fraction over 3, it can be written as 6 pi over 3. In order to find a positive coterminal angle, keep adding 2 pi to this angle until it becomes positive. Take negative 8 pi over 3 plus 2 pi. We know that 2 pi is 6 pi over 3. Negative 8 pi over 3 plus 6 pi over 3 is negative 2 pi over 3. So that's the same as secant of negative 2 pi over 3. Again, this angle is negative. Keep adding 2 pi until it becomes positive. Take negative 2 pi over 3 plus another 2 pi. Keep adding 2 pi until it becomes positive. And we know that 2 pi is 6 pi over 3. Negative 2 pi over 3 plus 6 pi over 3 is 4 pi over 3. This is positive. So next, secant of negative 2 pi over 3 is the same as secant of 4 pi over 3. This angle is between 0 and 2 pi. So that's a coterminal angle between 0 and 2 pi. Next, to make it a little easier, we can try to change this angle to degree measure. For 4 pi over 3, if we multiply an angle by 180 over pi, I can cancel pi from top and bottom. What's left is 4 times 180 over 3. Let's do division first. 180 divided by 3 is 60. 60 times 4 is 240 degrees. So 4 pi over 3 is the same as 240 degrees. 240 degrees, this angle lies in quadrant 3. 240 degrees, this angle here lies in quadrant 3. If an angle lies in quadrant 3, its reference angle is the angle itself minus 180 degrees. 240 degrees minus 180 degrees is 60 degrees. That's a reference angle. Since that's a reference angle, its trigonometry value is exactly the same. Its trigonometry value is exactly the same. The only difference is the plus or minus sign. Here, this angle, 240 degrees, lies in quadrant 3. And secant in quadrant 3. Secant in quadrant 3 is negative. Secant in quadrant 3 is negative. So this negative secant 60. Secant 60, that's one of the special trigonometry values. Secant of 60 is 2. So the final answer is negative 2. Carry negative sign. The final answer is negative 2. Next, let's look at some different examples. Based on the given information, find all 6 trigonometric ratios of angle theta. First example, sine theta is negative 1/3. Secant theta is greater than 0. Find all 6 trigonometric ratios of angle theta. First step, let's determine the quadrant of angle theta first. Let's determine which quadrant does angle theta lie. Here, sine theta is negative 1/3. If sine theta is negative, that means angle theta either belong to quadrant 3 or quadrant 4. Because sine function is negative in quadrant 3 and quadrant 4. Sine function is negative in quadrant 3 and quadrant 4. Next, we know that secant theta is greater than 0. Secant theta is greater than 0. We know that secant is positive in quadrant 1 and quadrant 4. Secant is positive in quadrant 1 and quadrant 4. So theta either belong to quadrant 1 or quadrant 4 based on secant. Theta either belong to quadrant 1 or quadrant 4. We can see that the common quadrant here is quadrant 4. The common quadrant here is quadrant 4. So based on this information here, we know that angle theta belong to quadrant 4. Based on this information, we know angle theta belong to quadrant 4. Next, we try to find all 6 trigonometric ratios using the reference angle. We try to find all 6 trigonometric ratios using the reference angle. If sine theta is negative 1/3, its reference angle, sine theta bar, is always positive. This reference angle is a Q angle. Sine theta bar is positive 1/3. Next, draw a triangle based on its reference angle. Draw a triangle based on its reference angle. Assume theta bar is here. We know that sine is opposite over hypotenuse. Sine is always opposite over hypotenuse. So opposite is 1. Hypotenuse is 3. Next, find adjacent using Pythagorean Theorem. Pythagorean Theorem is always a squared plus b squared equal to c squared. We treat these 3 sides a, b, c. C is always hypotenuse. So treat these 3 sides a, b, c. A is missing, b is 1, c is 3. We have a squared plus 1 equal to 9. Subtract 1 from both sides. a squared is a. A by itself is square root of a. Square root of a can be reduced as 4 times 2, and square root of 4 is 2. We get 2 radical 2. So a is 2 radical 2. And the missing side here is 2 radical 2. Next, find all 6 trigonometric ratios. We know that for angle theta, since its reference angle is theta bar, so all its 6 trigonometric values must be exactly the same. The only difference is the positive negative sign. So their 6 trigonometric values must be the same. The only difference is the plus minus sign. Let's write down the value first, and we'll fix the plus minus sign later. Let's write down the values first, and we'll fix the plus minus sign later. So for sine theta, we can use the reference angle. Opposite over hypotenuse. Opposite over hypotenuse. Leave some space in the front. We'll fill in the sign later. Sine theta is opposite over hypotenuse. Cosine theta is adjacent over hypotenuse. Cosine theta is adjacent over hypotenuse. Tangent theta is opposite over adjacent. Tangent theta is opposite over adjacent. Cotangent theta is adjacent over opposite. Adjacent over opposite. Leave some space in the front. We'll fill in the sign later. We'll fill in the plus minus sign later. Leave some space in the front. Secant theta. Hypotenuse over adjacent. Hypotenuse over adjacent. Cosecant theta. Hypotenuse over opposite. Then fill in the sign. Angle theta is in quadrant 4. Sine and cosecant is negative in quadrant 4. Sine and cosecant is negative in quadrant 4. Sine and cosecant is negative in quadrant 4. So cosecant here is negative 3. Cosecant theta is negative 3. Cosine and secant in quadrant 4 is positive. Cosine and secant in quadrant 4 is positive. If a number is positive, we don't need to write the sign, leave it blank. If a number is positive, we don't need to write the sign, leave it blank. Tangent and cotangent in quadrant 4 is negative. Tangent and cotangent in quadrant 4 is negative. So tangent is negative in quadrant 4, cotangent is negative in quadrant 4. That can be rewrite as negative 2 radical 2. That's cotangent theta in quadrant 4. Next example. Cosine theta is negative 2 over 5, and tangent theta is less than 0. How can we find all 6 trigonometric ratios of angle theta? First step, determine the quadrant. Determine what quadrant does angle theta lie. Here, cosine is negative. Since cosine is negative, we know that cosine function is negative in quadrant 2 and quadrant 3. Cosine function is negative in quadrant 2 or quadrant 3. If cosine is negative, that means angle theta either belong to quadrant 2 or quadrant 3. Here, tangent is negative. Tangent theta is negative. If tangent is negative, that means angle theta either lies in quadrant 2 or quadrant 4. If tangent is negative, that means angle theta either lies in quadrant 2 or quadrant 4. The common quadrant here is quadrant 2. The common quadrant is quadrant 2. So altogether, we can say that angle theta lies in quadrant 2. The common quadrant here is quadrant 2. That means angle theta lies in quadrant 2. Next, we try to use reference angles to find all 6 trigonometric ratios of angle theta. Since cosine theta is negative 2 over 5, cosine of theta bar for cosine of the reference angle is always positive 2 over 5. We drop negative sign. Since theta bar, the reference angle is always a acute angle, its trigonometric value is always positive. So for cosine of theta bar, we drop negative sign, write 2 over 5. Next, draw a triangle based on this information here. Draw a triangle based on this information here. Theta bar is here. Cosine is always adjacent over hypotenuse. Cosine is always adjacent over hypotenuse. That's adjacent, that's hypotenuse. Next, use Pythagorean Theorem for the missing side. Use Pythagorean Theorem for the missing side. We know that Pythagorean Theorem says a squared plus b squared equal to c squared. We treat these three sides, a, b, and c. C is always hypotenuse. Let me treat these three sides, a, b, and c. So a is 2, b is missing, c is 5. Solve the equation, 2 squared is 4. 5 squared is 25. Subtract 4 from both sides. B squared is 21. So B is square root of 21. B is square root of 21. Once we know B, once we know ABC, we can find the 6 trigonometric ratios based on the reference angle. The trigonometric value of theta is exactly the same as theta bar, since that's the reference angle. The only difference is the plus or minus sign. So let's find the value first and fill in the sign later. Find the value first, then fill in the sign later. Sine is opposite over hypotenuse. Leave some space in the front. We will fill in the sign. We'll fill in the plus or minus sign later. Cosine is adjacent over hypotenuse. Tangent is opposite over adjacent. Cotangent is adjacent over opposite. Secant is hypotenuse over adjacent. Leave some space in the front. We have to fill in the sign later. Cosecant is hypotenuse over opposite. Next, fill in the sign. Here, angle theta lies in quadrant 2. Angle theta lies in quadrant 2. We know that sine and cosecant is positive in quadrant 2. Sine and cosecant is positive in quadrant 2. So sine and cosecant is positive in quadrant 2. If the value is positive, we don't write plus sign, leave in the way it is. If the value is positive, leave in the way it is. We don't write plus sign. Cosine and secant in quadrant 2. Cosine and secant in quadrant 2 is negative. Cosine and secant in quadrant 2 is negative. So cosine and secant in quadrant 2 is negative. And tangent and cotangent in quadrant 2 is also negative. Tangent and cotangent in quadrant 2 is also negative. Next example. Tangent theta is 3. Cosecant theta is less than 0. We try to find all 6 trigonometric ratios of angle theta. First step, let's determine the quadrant. Determine what quadrant does angle theta lie. Here, tangent theta is positive. If tangent theta is positive, we know that tangent is positive in quadrant 1 and quadrant 3. Tangent is positive in quadrant 1 and quadrant 3. That means angle theta, if tangent is positive, that means angle theta is either belong to quadrant 1 or quadrant 3. Here, cosecant theta is negative. Cosecant theta is negative. We know that Cosecant theta is negative in quadrant 3 or quadrant 4. Cosecant theta is negative in quadrant 3 and quadrant 4. If cosecant theta is negative, that means angle theta either belong to quadrant 3 or quadrant 4. Here you can see that the common quadrant is quadrant 3. The common quadrant is quadrant 3. So based on this information here, angle theta belong to quadrant 3. Next, let's try to use reference angles to find all 6 trigonometric ratios. Let's try to use reference angles. When we use reference angle is always positive. So this angle, this number is positive, so we can use 3 directly. If this number is negative, drop negative sign. Since reference angle is a cube angle, its trigonometric value is always positive. Since reference angle is a cube angle, its trigonometric value is always positive. And 3 can be rewritten as 3 over 1. Next, let's draw a triangle based on angle theta. Tension is opposite over adjacent. Tension is opposite over adjacent. So that's an opposite, that's adjacent. Next, use Pythagorean Theorem, find the missing side. Use Pythagorean Theorem, find the missing side. The formula is a squared plus b squared equal to c squared. Let's train these three sides, a, b, and c. C is always a hypotenuse. Let's plug in. A is 1, b is 3, c is missing. So you get 1 plus 9 equal to c squared. 1 plus 9 is 10. Then take square root. C is square root of 10. That's the missing side. Next, based on the reference angle, find all 6 trigonometric ratios. Since this is reference angle, this is a reference angle, its trigonometric value of angle theta is exactly the same. Its trigonometric values is exactly the same as angle theta. The only difference is the plus minus sign. The only difference is the plus minus sign. Let's find the values first, then fill in the plus minus sign later. Let's find the values first, then fill in the plus minus sign later. Sine theta is opposite over hypotenuse. Opposite over hypotenuse. Leave a little space in the front. We need to fill in the sign later. We need to fill in plus minus sign later. Cosine theta is adjacent over hypotenuse. Tangent theta is opposite over adjacent. Cotangent theta is adjacent over opposite. Secant theta is hypotenuse over adjacent. Cosecant theta is hypotenuse over opposite. Next, let's determine the positive negative sign. We know that angle theta lies in quadrant 3. In quadrant 3, sine and cosecant is negative. Sine and cosecant is negative in quadrant 3. So, sine and cosecant, they are negative in quadrant 3. Cosine and secant, they are negative in quadrant 3. Cosine and secant, they are negative in quadrant 3. So cosine and secant, they are negative in quadrant 3. And tangent and cotangent, they are positive in quadrant 3. If it's positive, we leave it blank. We don't write plus sign, leave it blank. Then here, 3 over 1 is the same as 3. Negative vertical 10 over 1 can be rewritten as negative vertical 10. Those are the 6 trigonometric ratios of angle theta. Next example. Cotangent of theta is negative radical 2. Cosine of theta is less than 0. Find all 6 trigonometric ratios of angle theta. First step, let's determine the quadrant. What quadrant does angle theta lie? Here we know that cotangent theta is negative. We know that cotangent is negative in quadrant 1, is negative in quadrant 2 and quadrant 4. Cotangent is negative in quadrant 2 and quadrant 4. If cotangent is negative, that means angle theta lies either in quadrant 2 or quadrant 4. And also we know that cosine theta is negative. Less than 0 means it's negative. Cosine theta is negative. If cosine theta is negative, we know that cosine theta is negative in either quadrant 2 or quadrant 3. Cosine theta is negative in either quadrant 2 or quadrant 3. That means angle theta either belong to quadrant 2 or quadrant 3. And that's the common region. Quadrant 2 is the common region. Based on this information here, we know that theta belong to quadrant 2. Next, let's draw a triangle based on the reference angle. Let's draw a triangle using the reference angle. Cotangent theta is negative radical 2. That means cotangent of the reference angle. Cotangent of theta bar is positive radical 2. Because the reference angle is a acute angle, its trigonometric value is always positive. The reference angle is a acute angle, its trigonometric value is always positive. So that's cotangent of theta bar. Radical 2 can be rewritten as radical 2 over 1. Radical 2 can be rewritten as radical 2 over 1. Next, let's draw a triangle based on this information here. Let's theta bar. Cotangent is always opposite over adjacent. Cotangent is always opposite over adjacent. Next, we can use Pythagorean Theorem to find the missing side. Pythagorean Theorem says a squared plus b squared is always c squared. We treat these three sides a, b, and c. C is always an hypotenuse. Here a is 1, b is radical 2, c is missing. 1 squared is 1. Radical 2 squared is 2. 1 plus 2 is 3. So c squared is 3. For c, I take square root. I get c equal to square root of 3. That's the missing side here. Next, based on this triangle, find all 6 trigonometric ratios. Since theta bar is a reference angle of angle theta, its trigonometric value must be the same as theta. The only difference is the plus minus sign. So let's find the value first, then fill in the plus minus sign later. For sine theta, sine is opposite over hypotenuse. Leave some space in the front. We'll fill in the sign later. We'll fill in the plus minus sign later. Sine is opposite over hypotenuse. Cosine is adjacent over hypotenuse. Tangent is opposite over adjacent. Cotangent is adjacent over opposite. Secant is hypotenuse over adjacent. Cosecant is hypotenuse over opposite. Then fill in the sign. Fill in the plus minus sign based on angle theta. Fill in plus minus sign. Here, angle theta belongs to quadrant 2. Angle theta belongs to quadrant 2. We know that in quadrant 2, sine and cosecant, they are passive. In quadrant 2, sine and cosecant is passive. So sine and cosecant is passive. If a number is passive, leave it blank. Don't need to write plus sign here. Leave it blank. So sine and cosecant is passive. In quadrant 2, cosine and secant is negative. In quadrant 2, cosine and secant is negative. So cosine is negative, secant is negative. And also, in quadrant 2, tangent and cotangent is negative. In quadrant 2, tangent and cotangent is negative. So tangent and cotangent is negative in quadrant 2. And here, tangent is negative radical 2 over 1. That can be rewritten as negative radical 2. Secant is negative radical 3 over 1. That can be rewritten as negative radical 3. That's the values of 6 trigonometric ratios of angle theta. Next, let me show you some trigonometric identities. We know that in the coordinate plane, sine theta is always y over r. Cosine theta is always x over r. Tangent theta is always y over x. And cotangent theta is always x over y. Secant theta is always r over x. And cosecant theta is always r over y. Based on these 6 identities, we can see that sine and cosecant, they are reciprocals of each other. Cosine and secant, they are reciprocals of each other. Tangent and cotangent, they are reciprocals of each other. If I flip sine over, I get cosecant. If I flip cosine over, I get secant. If I flip tangent over, I get cotangent. So sine and cosecant, cosine and secant, tangent and cotangent, they are reciprocals of each other. So memorize this. Cotangent theta is always 1 over tangent theta. Secant theta is always 1 over cosine theta. And cosecant theta is always 1 over sine theta. Memorize these three identities. Next, let me show you more identities. What if I take sine divided by cosine, then what do we get? If we take sine divided by cosine, what do we get? If we take sine theta divided by cosine theta, what do we get? We know that sine theta can be rewritten as y over r. Cosine theta can be rewritten as x over r. When we have a fraction divided by fraction, we keep the top the same. Flip the bottom over. Then r can cancel. What's left is y over x. And y over x is exactly the same as tangent. Y over x is exactly the same as tangent. Which means sine theta over cosine theta is always equal to tangent theta. That's another identity. Now, how about cosine theta over sine theta? How about cosine theta over sine theta? We know that cosine theta is x over r. Sine theta is y over r. When we have a fraction divided by fraction, we keep top fraction the same. Flip the bottom fraction over. R get cancelled. What's left is x over y. And we know that x over y is cotangent theta. So, based on this expression here, we know that sine theta over cosine theta is always tangent theta. cosine theta over sine theta is always cotangent theta. Keep these two identities in mind. Sine theta over cosine theta is always tangent theta. Cosine theta over sine theta is always cotangent theta. Keep these two identities in mind. Next, let me show you more. How about sine square plus cosine square? How about sine square theta plus cosine square theta? What do we get? If I take sine square theta plus cosine square theta, what do we get? We know that sine square theta, sine is y over r. So sine square theta can be written as y over r square. Note, in general, for sine theta square, we write it as sine square theta. They are exactly the same. For sine square theta, for sine theta square, we write it as sine square theta. That's the notation for sine square theta. In general, for sine theta square, write square here. That means sine square theta. But if there's no parentheses, sine theta square, this actually means sine of theta square. So don't be confused. If we write square here, that means sine theta, the entire function square. If I write sine theta square with no parentheses, that means sine of theta square. Be very, very careful. Sine square theta means sine theta square with parentheses. So here, sine square theta is y over r square, because sine theta is y over r. Cosine square theta, we know that cosine is x over r. Cosine is s over r. So cosine square theta can be written as x over r square. Then y over r square can be written as y square over r square. S over r square can be written as x square over r square. They have the same denominator. It can be written as y square plus s square over r square. We know that in the coordinate plane, r is always square root of s square plus y square, which means r square is the same as s square plus y square. So on the numerator, s square plus y square is r square. They equal to 1. So sine square theta plus cosine square theta is always 1. That's another identity. Next, based on this identity here, if I divide all three terms by sine square, what do we get? If I divide all three terms by sine square, what do we get? If I divide both sides by sine square, what do we get? If I divide both sides by sine square, what do we get? Sine square over sine square is 1. Cosine square over sine square can be written as cosine theta over sine theta square. 1 over sine square can be written as 1 over sine square. And we know that cosine over sine, cosine theta over sine theta is cotangent theta. It's cotangent square theta. And 1 over sine theta, 1 over sine theta is cosecant theta. I get cosecant square theta. That's another identity. 1 plus cotangent square theta equal to cosecant square theta. Now, for the same equation, What if I divide both sides by cosine? What if I divide both sides by cosine squared theta? For the same equation, what if I divide both sides by cosine squared theta? Then I get sine squared theta over cosine squared theta plus cosine squared theta over cosine squared theta equal to 1 over cosine squared theta. If I divide both sides by cosine, in this equation, if I divide both sides by cosine squared, I get this. Next, if I simplify, sine squared theta over cosine squared theta is sine theta over cosine theta squared. Cosine squared theta over cosine squared theta is 1, that can cancel completely. And 1 over cosine squared theta can be rewritten as 1 over cosine theta squared. And we know that sine theta over sine theta over cosine theta is tangent theta. So that's tangent squared theta plus 1. And 1 over cosine theta. 1 over cosine theta is secant theta. So I get secant squared theta. So tangent squared theta plus 1 is always secant squared theta. So memorize these identities. These identities and these three identities. Memorize these eight identities. Memorize these 8 trigonometric identities.